The third domain of the CISSP is called security engineering. It covers topics that include security models, selecting security controls, vulnerabilities of security architectures, cryptography, and physical security. The first topic to be discussed will be cryptography, which protects data during its different states of being stored, processed, and in transit. To have a better idea about cryptography, it is important to note the major milestones that have led us to the current state. It all started when people wanted to communicate messages with only the intended recipients being able to understand them. Cipher systems were one of the initial methods to encrypt messages, and the Caesar cipher is commonly noted as one of the first systems to be recorded. The concept of the system is to shift each letter of the alphabet a specific number of places to the left or to the right. For example, a shift of 2 letters to the right would mean that the letter B would be denoted as the letter D, and the letter C as the letter E, and so on. The Caesar cipher is therefore a substitution cipher, that uses one alphabet. To decrypt a message that has been encrypted with the Caesar cipher, one would simply reverse the shift in the opposite direction. Communicating messages during war or for military purposes has been a major motivator to advance the cryptography field. During the World War II, the German infamous Enigma machine was in use, which used a complex substitution cipher. Without having an actual Enigma machine, it was very difficult for the Allied forces to decrypt the messages that were being communicated by the Germans. Thanks to the Polish military, a prototype of the Enigma machine was reconstructed, and shared with the British and the Americans, who were able to break the Enigma code, and eventually became able to decrypt the intercepted messages. This incident has been contributed as one of the factors that allowed the Allied forces to have an upper hand in the war. The Japanese deployed a similar cryptographic machine codenamed the Purple Machine, with its cipher also broken during the war, thanks to parts of the machine being captured from the Japanese embassy in Germany. The goals of cryptography are to ensure the confidentiality, integrity, authentication, and non-repudiation of data. Confidentiality ensures that the data is kept private, in order to keep it safe or secret. Data confidentiality should be ensured when data is stored to protect it against theft, and when data is in transit to protect it against eavesdropping. Integrity ensures that the data has not been altered or modified by unauthorized parties, where the recipient would be sure that the message is accurate as communicated by the sender. Message digests or hashing techniques are used to ensure that the message has not been changed intentionally or by mistake during transmission. Authentication ensures that the intended parties are involved in the communication, where each of the correspondents proves his true identity to the other before sending any data. Finally, non-repudiation ensures that the message was sent by the real sender and not somebody pretending to be him, where at the same time the sender of a message can't deny having sent the message.